Hello everyone and welcome to the Change Makers, our series of open conversations on innovation in the stainless steel and alloys industry. Today we are pleased to welcome Charles David. You are new business advisor for mobility and transport. Thank you for being with us today.
Thank you, Eleanor, for having me.
So we will talk about an important type of components for the mobility revolution, which is nanocrystalline magnetic cores for power electronics. First of all, Charles, could you say a few words about Aperam?
Of course. So Aperam is a leading global stainless steel and nickel alloys producer. We have production facilities in Europe and in South America and operations in more than 40 countries. And since our inception, we're recognized for our strong commitment to the development of sustainable products. So I could mention, for example, our very low carbon footprint stainless steels and also our commitment to the recycling of these materials.
So as I mentioned in my introduction, you are new business advisor for mobility and transport, yet you're known for your engineer background. Tell us what's exactly your mission at Aperam.
Yes, so you mentioned my background. Indeed, I hold a PhD in metallurgy and corrosion, and I have some experience with material choice. And I would like to say that I'm passionate about all the potential for innovation that alloys and stainless can offer. And since last year, I'm part of the e-mobility new business team, and my role is to take all the technical knowledge that Aperam has and transform it into a real value proposition for our customers. So I like to say that my role is to make the bridge between highly technical topics and our business offer.
That's very interesting, and I think today we're going to talk specifically about magnetic cores, which is an obscure topic to me. Can you say why they are so important?
Yeah, you shouldn't be afraid of the word. So actually, inside an EV, an electric vehicle, you have different systems, electrical systems, which use power to work. But they need this power under different forms. The battery of the car stores this power under one form. So power electronics is there to transform that power into the power that can be used by the other systems. If you take the example of the inverter, which is the converter that transforms the DC current, so the direct current, coming from the battery into the AC current that is feeding the motor. When it does it, it will also generate an electromagnetic interference. And our magnetic cores are there to filter this interference in order to protect the other systems of the car.
Okay, I understand. But now let's focus on the nanocrystalline magnetic cores. What does the word nanocrystalline mean here?
Okay, so our magnetic cores are made of a metallic ribbon that is coiled, and this metallic ribbon is made out of a nanocrystalline alloy. So the name comes from there, actually. And the nanocrystalline alloy is composed mainly of iron, silicon, boron, and niobium. And it has very small, tiny little grains in its metallurgical microstructure. And that microstructure gives it special properties, special magnetic properties.
So amongst other products, why investing energy and time in developing this one?
Well, for three main reasons. The first one is that the market is booming right now thanks to the very fast growth of the EV market. The second one is that Aperam has a huge asset, which is our know-how that we have in magnetic cores for years for the aerospace industry, which, as you know, is a very demanding industry. And we have succeeded in taking our know-how in that area and apply it into the EV market. And the third reason is that we're not only talking about magnetic cores, we're talking about nanocrystalline magnetic cores. And these are very, very high added value cores, which are emerging right now as an alternative to the traditional ferrite cores. And they have advantages, for example, a better stability with temperature and also a higher permeability than ferrite cores.
And are there other advantages in using nanocrystalline cores?
Yes, I could mention, for example, the fact that nanocrystalline cores are smaller than ferrite cores, so it gives you more possibilities in terms of the designs of the parts. In the end, this will impact the total cost of ownership. So Today, nanocores are present in less than 1 EV inverter out of 3, but we believe that tomorrow, by 2030, it will represent more than half of the magnetic cores on the market.
And does Aperam produce other types of components for power electronics?
Yes, we also produce stem parts, which are used, for example, in electromagnetic shielding and current measurement.
That's fascinating to see the stakes behind the curtain and all the expertise that is called around an EV production. So, Charles, in a word, what would you like that we remember of the passionate subject of nanocrystalline magnetic cores?
Well, I would like those who are listening to us today to remember that the development of new materials and materials expertise is key in making the mobility revolution more affordable. Every step we make in making the components more performant is a step we make in making them also more competitive. And that's exactly what Aperam is doing with nanocrystalline magnetic cores.
Thank you very much, Charles, for making us understand such a technological subject. I felt for a while that I was an EV engineer. So see you soon for the next episodes of The Change Makers. In the meantime, if you want to continue this conversation with Charles, please contact him.